As Johannes just said, my name is Martha Lewis. I'm an architect and head of materials at Henning Larsen. And for the last 3 years, I've been working on an educational initiative that started in our office when I realized that the Danish building code was going to include requirements for CO2 emission on a life cycle basis. And I looked at all of my colleagues worldwide. We were at the time 750 people. And I thought, how are we going to raise the level of knowledge? How are we going to take this entire office so that they can begin to make much better decisions? Not only on the materials that are used, but hopefully also on which projects do we say yes to, which ones do we want to be involved with. So it's been a multi-year initiative. And the course that I developed, which is called Unboxing Carbon, and had all sorts of lovely graphics developed by our graphic team. Do you speak carbon? It was simply taking people who really hadn't thought about this before and giving them an entry point, and then within the 4-hour course, moving into the afternoon into quite an intensive how do you read an environmental product declaration, and how do you understand this data, and how can you make better choices out of what is right in front of you. So this was 3 years ago. We've come quite a long way. I have taught the course now to over 1,000 participants, not just in our office, but also beyond, particularly focusing on the Danish market. And what I have today is a bit of a spin through the course in a very abbreviated fashion. You all have a level of knowledge that is vastly greater than where I was 3 years ago, starting with people who really didn't understand the difference between embodied carbon or operational carbon, or CO2 versus what is carbon. So you're starting at a very different point, and I'm happy to say that I feel that the course is, for many audiences, a little bit out of date because people know it already, and that's fantastic. But I tried through the entire presentation of the course to always be addressing from a holistic, from a systems point of view. So started off with simply the triple planetary crisis, the multi-crisis, summarized very painfully accurately by the Stockholm Resiliency Center with planetary boundaries, and looking very specifically at the first three. I put the course in a framework of if we understand CO2 emissions associated with our buildings in a much better way, and we also have an understanding that biosphere integrity is also closely linked to the decisions we're making in terms of resource use. And also number 3, highlighting the first 3 here, the novel entities, that these 3 are the ones that the building industry has a serious impact on, and they're interrelated. So this is, the course is ultimately focused on education in terms of CO2 and the impacts from materials, but you can't understand that unless you also understand the interrelationships with loss of biodiversity and pollution. So in a ultra quick way, I will blast through the intro to the course, and that is simply this unfortunately burning platform, or burning planet, we could say, with the fantastic work coming out of NRK. If you haven't seen this is journalism at its very best, looking at in Norway the destruction of virgin forest to produce over 5 years 44,000 different plots for primarily for housing, individual family housing. But this is a fantastic piece of journalism. I recommend that everyone look this up. This is summarizing the impacts of the tight interrelationship between construction and our loss of biodiversity. And very briefly, the impacts from pollution also very tightly linked to loss of biodiversity, and the very unfortunately large role that construction industry plays in the use of chemicals in building products. And then the last, the carbon angle, all of you know the statistics that are on the slides here in terms of emissions from the construction industry. So there has been a very clear regulatory response, which we walk through in the course. And as I said, this was framed to position our architects to be quite well and aware of what they were going to have to do with their projects in a very short period of time. So in January of 23, the code came through. In the building code, we have this cap at 12 kilos CO2 equivalents per square meter per year over 50 years. And in a Swedish context, it's very hard to translate this, but you can start by multiplying the 12 by 50 years, so you're looking at 600 kilos of CO2. It's a bit hard to compare because you're looking at different phases. It's a little ironic that all of the countries in the EU are working under the same whole building life cycle assessment norm and standard. However, every national country has its own tweak in how this is calculated. So it makes it very difficult with cross-country comparisons. This, thanks to Reduction Roadmap, and thanks to Jeppe's presentation, I can speed through this, has been updated with the new requirements that will kick in next summer, 2025, and under pressure from the industry and from the Reduction Roadmap's excellent work, there are now different requirements per typology. This is not a requirement, this is a cap, I should say, with, I guess, the average being 7.1 kilos of CO2 per square meter per year. The European Union will also, through the Energy Performance of Buildings Directive, have caps for all new buildings starting in 2028 over a certain size, and then all buildings starting in 2030. So that's coming, and it will be up to the member states to set the caps. So we're really moving towards a stronger focus on calculating CO2 in the structures that we are working with. And hopefully also this will spread from not just new construction, but also to transformation and renovation projects. Part of the course is to constantly remind everyone that we have to listen to the climate scientists. We have to continually realign with the reports that are coming out that are constantly being updated and not necessarily always in a more positive direction, but the realities have to be confronted. And this is the background chart is from the 5 socioeconomic pathways out of the IPCC report, where you have do nothing or build as usual on this trajectory to a 5 to 8.5 degree warming by the end of the century. And if we just pop in some of these terms and phrases that we've heard today, and also some in the black, the regulations, we can see that the current building code is build as usual, so on track for the 5 degree warming. If we continue with the cap at 12, the Danish voluntary class, which is currently active at 8 kilos, is slightly better, but not meeting the Paris pledges. So the new code coming in is also not meeting Paris pledges. That would be the Reduction Roadmap's suggestion, calculations at 5.8. And anything, we really love this word regenerative and have unfortunately very few examples for it, but that work would be after an article that was published on planetary boundaries somewhere under 0.1 kilos of CO2 per square meter. And of course the response should be, but it's not just about per square meter, it's also about how many square meters we're building, and are we building new? So all of those aspects have to be considered when we're choosing materials. I have a slide from a Rio Dania project here. Again, this was looking at other best practice cases to see where are we in Denmark, how are we doing in relationship to all of these targets and ambitions with new construction. And the top line here is the building code. These are the best 24 best practice cases. So of course we're long below the building code. The voluntary class, 22 of the projects are underneath that. And then the 4-to-1 Planet project had a goal at 2.5 kilos. And none of the projects were meeting that. One was close. And if we were looking at this planetary boundary ambition, we're not quite there yet. Certainly not with new construction. I think there is a very, very good argument on the screen here for a moratorium on new construction. So what does this mean for materials? Some very clear conclusions here that we simply need to be very clear in every decision we make on our material selections. And this is true for renovation as well as new construction. So part of the course is really understanding what are the impacts that are from different materials and then looking at the relationship to their global warming potential numbers. And part of the course is also digging down into the data to understand what is it that is in the EPDs. Can we translate that to a more graphic expression of data with a picture, with some basic fundamental data to understand what the product is, and then looking at it per square meter so that we can begin to do comparisons, always, of course, being aware of what thickness is being used. But part of the afternoon part of the course is to look at how do we produce these catalogs and work in a way that also communicates with our design architects who have no desire to ever look at any numbers but just want to be creative. So we needed to find a very clever way to present data so that it would come home to them as well. So the catalogs we've just re-released 2 catalogs, one with interior materials and this one is from the exterior with new updates, so all the data is current and again per square meter, and we're looking at the upfront carbon, the A phases here. I have one case from Henning Larsen, the Earthshot project, which is a residential project in Copenhagen in Nordhavn with the client NREP, and this project started with a very slow and long several years of workshops trying to establish a methodology and trying to establish ambitions that were achievable, yet still very ambitious. Hence the name Earthshot. We don't want to be leaving the Earth and going to the moon, but we need to do the best we can on the Earth. And the team, client and consulting team came up with a target in 2022 of a max per square meter of 5 kilos of CO2 for new construction. And what I have here are just some a stream of slides from an early phase. These products have not necessarily, and these proposals have not necessarily come through. It has been a very interesting process of how do you work from the early phase with very strong ambitions, and how do you then keep that all the way through, also when the contractor comes on board and pricing is highly relevant. So the project has evolved to be a really interesting constant calculation and constant reevaluation of the materials that are being selected, where we started with a focus on can we work with as much biogenic as possible, and what does that then look like in the different building component structures. So the roof assembly, working with wood fiber insulation and timber framing. Exterior walls, we looked at many different options. This is one of them that was in play. We're looking at straw insulation elements, the Eco Cocoon system, and with clay boards. Yeah, I should be holding them up as I speak, right? Everything's on display right here. You don't need the slide. And as I said, constant calculation on the different options. And this is still a live calculation because we have price in there now as well. So we have the low end of an EPD Working generically, if we choose this product, we would be at the lowest end. If we choose this other product, we're at a high end. Can be the same product. It's just different EPDs. We're playing with the entire spectrum. What if it was bought from this manufacturer versus if it was bought from the other manufacturer? So it's been a very interesting process. And also looking at what is the impact then? Is this 0.6% of the entire project's global warming potential, or is this a much larger percentage? So we have our calculation caps on. Interior walls, living board, hemp fiber, clay board, and clay plaster. Some of these are still in the project. Floor assemblies, looking at the LVL wood deck from Ligna Trend, and cork panels. But the only way, the conclusion is simply we focused on trying to get as much biomass in, looking very specifically at materials that have a rapid harvest cycle. But the only way that we're getting to 5 is by using a lot of reused materials. So we're using at least 18 different parties of materials coming from a specific project where the timing was good. It was coming down just as this the Earthshot project is going up. So this was essential to coming into under target. So rounding off here, I can't help but put it on the screen, this question of responsibility, culpability, blameworthiness, and in a legal discussion, the discussion of culpability involves a question of knowledge. Did we know? What did we know? What decisions did we make knowing what we know? And then how you live with that. And I think that is a very relevant discussion for our office. We are continually engaging in this schizophrenic challenge that we have as practitioners. How can we shift our practice so that we are less uncomfortable every day? Back to the planetary boundaries, and then again addressing what are the conclusions to 1, 2, 3. What can we as an industry come with in response to biosphere integrity? What can we come with as a response to climate change, and also with novel entities? And just to be as simple as possible in my proposals here, no greenfield projects. I would say no agricultural land either. We should simply not be building there. We should build radically less, renovate, transform, reuse, and repurpose. And in terms of chemicals, we need to raise the level of awareness in terms of chemical pollution. We cannot be using products with carcinogenic, mutagenic, reprotoxic, and endocrine disruptors, as well as persistent biological toxins. So what we have been pushing the industry to do is to look at this approach to sustainability, the triple bottom line, people, planet, profit, which has been the song of the sustainable certification systems for many, many years now, for 25 years. And we need to reassess that. And we simply cannot have this addressed in an equal balance. It's been said over and over, as long as these three are in an equal balance, we will have sustainable projects. This is simply not the case. Until we begin to prioritize one of those, and that's the important one that you can't see because it's blocked out here, and that's the planet. Until the planet becomes the main driver for our decision-making processes, we don't have a future on the planet. But if we prioritize the planet, then we have the potential for a much more harmonious future, prosperity for the people who are living on the planet. Thank you.